Hello everyone, I hope you all are doing fine. This is a new module on transportation engineering. This is pavement materials. In our last two modules, we have covered geometric design and traffic engineering. In this new module, we are going to learn about different pavement types. We have two pavement types. One is a flexible pavement and another one is a rigid pavement. The materials used in the different layers of these pavements are very important. So we will discuss the different properties of these materials and how these properties changes the quality of a pavement. Talking about pavement, pavement is the paved path on which your vehicle run. If you see on ground there is soil all around. We cannot use that ground to move our vehicle because soil may be soft, it may be having undulations, it will not be able to take load of heavy vehicles. So we have to pave a path so that the riding quality can be better, the support from the soil underneath or the material underneath increases. So talking about the pavements, we have two types of pavement. One of which is known as your flexible pavement, and another one is your rigid pavement. Flexible pavement is consists of number of layers. The topmost layer is known as surface course. Surface course is the topmost layer and is having the best riding quality. This material, or sorry, this layer is made up of your bituminous binder and your aggregates. Bitumen is a kind of viscous material which comes from petroleum crude. We will study about bitumen and how it is extracted, but you should understand it is a viscous material and it is mixed with aggregate in order to get a comparable mix which is laid over the surface, rolled with rollers, and it is made smooth in order to have a better riding quality. Then a layer which is supporting your surface course is known as your base course. It is a layer of broken stones which supports your surface layer. These broken stones are quality aggregates which allows the water to move through it. We have made arrangements of camber to flow off the water which is coming from rain. But if some water remains on the surface, it will move through the base course. We don't want any water to remain on the surface because surface will get deteriorated with the presence of water. Another layer which supports your base course is sub-base course. Sub-base course is also made up of broken stones, but the quality of these broken stones is not as good as base course. This layer supports the load coming from top and it distributes the load from top to the layer beneath, and the layer beneath is known as subgrade. Subgrade is the lowermost layer and it is the stabilized soil. Soil should be having enough bearing capacity to bear the load of moving traffic. we will be having heavy trucks, heavy movement of your defense vehicles. So these loads should be sustained by some base. That's why we stabilize the soil present in the area in order to have desired bearing capacity. Now if you see, we have another layer. This is actually not a layer, this is a process of making embankment. You know that the road profile is comparatively smooth. Smooth means if it is going down, the slope will be smooth. Slope does not change very frequently. It is made to last longer. If we are going up, the slope is smoother. We don't have undulations. So if undulations are present, to make a smoother slope, we have to make cuts or fills. The cutting of undulations and filling of the depressions is a process which is used to make embankment. So this embankment is actually the cutting and filling process. Of the area. This flexible pavement has another friend, another type of pavement, which is known as rigid pavement. This rigidity comes from its surface only. The surface course on rigid pavement is actually a slab made up of concrete, or you can say cement concrete. This slab provides the load distribution in terms of slab action. Means the load distribution will start from here. The load will be distributed in slab action. Whereas in flexible pavement, load was distributed with the help of particle to particle contact. This particle which is having load will distribute the load to other particles. That's why the pavement is known as flexible pavement. And because of slab action, because of the rigidity of the slab, we have rigid pavement. The slab is supported by base or sub-base core. There is only one layer which supports your slab. And the base or sub-base is supported by your subgrade, similar to your flexible pavement. This is also stabilized soil. In rigid pavement also, we need embankments, which is cutting or filling. So the main difference is of surface course or the load distribution pattern. The binder which is used for flexible pavement is bitumen, and for slab it is cement. Here we have the shoulder area. The shoulder is present on both rigid and flexible pavement and is generally made up of stabilized subgrade, a filled subgrade with stabilized surface. This is also, we have studied, is used as additional lane. It should be rough as compared to pavement, but the strength should be enough in order to sustain the moving load. So these are the two pavement surfaces or pavement cross sections which we have seen now, and we have rough idea what kind of material are being used in construction of this pavement. So let us move to look what materials are being used. First, the most important is your soil. Your subgrade in your shoulder, the soil is used. Then aggregates. aggregate are mixed with binders and are placed on the surface. They are used in base and sub-base code. Aggregates may be natural or artificial. Then we have bitumen, tar, emulsion or cutback. We will study when we will talk about bitumen about tar, emulsion and cutbacks. These all are some kind of bitumen only or kind of binder only. Then we have modified bituminous binder. When some additives are added into the bitumen in order to enhance its properties, then it is known as modified binders. Like, for example, the waste tires are added, then we call it rubbered modified binder. If waste material is added like plastic, we have different kind of binder. So we use some kind of polymer, some kind of additives in order to enhance the quality of binder. So these are known as modified bituminous binders. Then we have bituminous mix, the mix of your binder, bituminous binder and your aggregate. This is known as bituminous mix. Talking about your rigid pavement, we have binder, which is cement. Then we mix binder with aggregate. With help of water, we make concrete, which is known as cement concrete. Cement concrete can be plain concrete. Plain means without those steel bars. It may be reinforced concrete. With the help of steel bars, we provide more strength to this cement concrete. Or it may be pre-stressed. Pre-stressed means a high level of compression is introduced these slabs so that the condition of tension cannot be, because the cement concrete is very good in compression, but it does not take tension. It fails in tension. So we don't want tension force to be there in the cement concrete. Then we have stabilizing material. Stabilizing material, the material which is used to stabilize your soil. What does we mean by stabilizing? Stabilizing means whenever the soil is changing its properties with moisture, we want it to stabilize, to come to a single property which we can alter by rolling or by other operations. To make it stabilize, we add uh, materials like lime or cement. We will talk about stabilizing materials. Then we have recycled materials. Recycled materials which are used in different other materials so that we can reduce the cost of construction. A very important addition to your pavement material is geotextile or geomembrane. These days, a layer of geotextile is being added to your subgrade in order to increase the stability. We will have an idea what is a geotextile or a geomembrane and how it is used. So these are the pavement materials which we will see in coming lectures. Let us start with soils. Soil are used in subgrades, embankments, and shoulders. They are used in processed or in a stabilized form or in natural form. If soil is stable enough to sustain the moving loads, then we are in a condition to use that natural soil. But if it is not stabilized, it is not in the condition to be used as it is, we have to process it. That's why we use it in processed or stabilized form. Index properties and the mechanical properties are the main properties of soil which we focus on. because these properties tells us about the quality of the soil or the type of the soil. Soil can be classified in Indian classification system, which is based on particle size distribution and index property. It is also classified in unified classification system, which is based on gradation and Atterberg's limit. Atterberg limit, you know that Atterberg limit are liquid limit, plastic limit, shrinkage limit. Then soil can also be classified by HRB, Highway Research Board, or ASTO method. This is generally represented in terms of GI value. GI is your group index. All these classification you have already studied in your soil, in your geotechnical engineering. So we need not to revise it. You can go back to your geotechnical lecture and see what classification systems are these and what Atterberg limit can be and how these can be calculated. In the comment box, I want you to write the full form of ASTO. This is an agency which gives various directions, codes, or specifications in order to construct a road. So I want you to search and remember the full form of ASTO. If you cannot, I will tell you in other classes. It is not Indian, it is American. So search what is the full form of ASTO and remember it. The soil strength depends on soil type, because granular soil has better strength compared to fine grained soil. Particle size distribution, because the particle size distribution helps in gradation. If particle to particle contact is more, means these voids are properly filled, then we will have more cohesion, we will have more internal friction, and these are the properties which affects your strength. Degree of compaction. Compaction means when these voids are removed by external force, and we know that a compacted soil has higher strength. Then it is moisture content. Moisture content is a very important property which may affect your soil strength drastically, because with increase in moisture content your strength will decrease. Permeability is the property in which soil allows drainage of water through it. If it holds water, it do not allow the water to drain, the shear strength or the strength will decrease. So there should be proper drainage available in the soil, drain of water. So these are the properties which affects the strength of your soil. Let us see different tests in order to check different strengths of the soil. Soil may be having shear strength, bearing capacity. So to test these strengths, we have shear test. Shear tests are actually lab based or laboratory based and site based also. The lab based tests are shear box test, that is also known as direct shear test, your triaxial shear test, and your unconfined compressive strength test. You have already seen these tests in your geotechnical engineering. You can revise it by revisiting those lectures. Bearing capacity test is a field test which is known as plate load test, which is a very important test for your highways, because we need to know whether the soil present can bear the coming loads. If the soil is not able to bear the coming loads, we have to add some additives and stabilize the soil to make it capable of taking external loads. Then we have penetration test. Penetration test also tells us about the resistance of soil against the penetration of plunger. We will talk about CBR test, and the CBR test gives us CBR value which is used for design of flexible pavement. Our codes use CBR value to design flexible pavement. So let us see these two important tests. One is plate load test and CBR test. Let us see how these are done and what are the specifications which we use for conducting these tests. These plate load tests are done to evaluate the subgrade, the base, and maybe sometimes the complete pavement. But generally these are done for subgrades only. The data which we obtain is used for design of flexible pavement and rigid pavement. What is done, you can see in the image. This image is obtained from Google Images. You can find these images and you can observe the changes by yourself. Here is the arrangement of loading, and here we have a circular plate. These circular plates are placed at the level of subgrade and then load is applied. For how much load, what settlement is occurring, this is noted, and then this settlement and the load is used to calculate the modulus of subgrade reaction. Let us see what are the specification of this test. So plate load test is done in accordance with IS 9214 1979. This IS code is specifically for calculating modulus of subgrade reaction. K value. We'll talk about what this K value is, but actually you have IS 1888 for plate load test, but for specifically for highway or subgrades, we have this code. So we should follow this code. So in this test, what is done? Let us see the diagram. This is your level at which you are performing your test. This may be your subgrade level or the level at which you want to perform the test. So a pit is dug, plate of a specific area is placed here. So the plate here used is or let us write here only, the plate which is used is around 300 mm to 750 mm dia plate. For highways, 750 mm dia plate is used. You can star mark it. What is used? 750 mm dia plate is. You should remember this. This plate has other plates placed over another plate for load distribution. Then with the help of jacks and loading arrangement, what we have already seen in Let us make a truss here for loading arrangement. So this is the loading arrangement. Loads are applied from above, and these loads are measured with the help of dial gauges which are placed on these checks. There is another dial gauge which is placed on the lowermost plate to calculate the strain or the deflection or the settlement. This is for load. So this is the arrangement of your plate load test. So we know that test is done at the level of subgrade, plates of dia 750 mm. The plates are available from 300 mm to 750 mm, but for this specifically for roads we use 750 dia plate mm is placed over horizontal surface. So this base is made horizontal. Coarse sand is distributed and it is compacted and checked with the help of bubble tube, that if it is not horizontal, then again the processing of that level is done. Then a load of 0.07 kilogram per centimeter square is applied. So what is this load? We can write this is around 320 kg for 750 mm plate. Why this is applied? This is applied in order to make the surface smooth, make the surface horizontal. The initial undulations can be removed and this load can stabilize the soil below. So this is the initial load. The working load is applied to make any surface irregularity removed. If there is any surface irregularity, with this load, it can be removed. The load is then removed and dial gauges are set to 0 again. This load is removed and the dial gauges again, because of this load there may be some settlement, there may be variation of load in the load dial gauge. So these loads are removed and all the dial gauges are again set to 0. Then the loading starts. Load is applied to give a settlement of 0.25 mm. So load is applied to give a settlement of 0.25 mm or a rate of settlement of 0.025 mm per minute. This is for your worst condition like for clay with lot of moisture. We know that when there is clay with moisture, the applied load is taken by the moisture itself, the moisture present in the voids. The load gets dissipated with time. So better to apply or to get the load dissipated, we apply gradual loading. And the gradual loading is applied such a way that the settlements which are visible is 0.025 mm. But if it is gravel or sand, the settlement is made up to a level of 0.25 mm with the application of load. There is no problem of the moisture taking the applied load. Now the weight is noted. The weight or the load is noted at a level of 0.25 mm. This process is continued till the settlement is 1.75 mm. So for every 0.25 mm settlement, load values are noted up to a total settlement of 1.75 mm. So the total settlement is 1.75 mm and the load of for each 0.25 mm is noted. Then a graph is made. So this is the arrangement which you see. This is the plate. Thickness of this plate here, the thickness of this plate is around 0. Or you can write is in mm, it is 25 mm. Thickness of this plate is 25 mm. Other plates of smaller diameters are placed over it. So we can say this plate is 450 mm, then 300 mm plates are placed over it to prevent the bending of the lowermost plate because of this applied load. So this is the arrangement. This is your plate. You can see there is depression. The dial gauges are, this is your arrangement of your dial gauge which is noting the settlement. These are your loads. So with the help of this arrangement, a graph is made between load and settlement. Load in million Newton per centimeter square and your settlement in mm or in centimeter. A graph is made and graph comes out to be curved this way. Theoretically it should be a straight line, but practically it comes out to be curved. For a value of 1.25 settlement, the load value is noted, and this graph is made straight by joining origin with this section point. And the slope of this line which we have made is known as your K. K is the slope of load settlement curve for a settlement value of 1.25 mm or 0.125 centimeter. These values you should remember. These are directly asked in examination. So the slope of this curve is known as modulus of subgrade reaction. This value is calculated with the help of this graph. So the modulus of subgrade reaction K can be written as load applied P or the stress applied P upon your delta, means settlement. And for K value, this settlement should be 0.125 centimeter. The P value is your million Newton per centimeter square. So the combined unit of K, unit for K is million Newton per centimeter cube. This is a very important unit to remember. This is a modulus of subgrade reaction. There are different cases which may occur in this arrangement. What are the different cases? Like case 1, to make measurements for worst condition. What is worst condition? Worst moisture condition. Soaked K value should be measured. Soaked K value is what? Soaked means you apply water at that location, soak it for some time, and then test is done. Soaked condition give you a critical value of slope, this modulus of subgrade reaction, so that we can make the arrangement over safe, because at some time in the lifespan of that pavement or surface there will be a condition of the water logging, maybe heavy rainfall, maybe some flood. There may be a condition when the subgrade is completely soaked. So to replicate that condition, we should measure soaked K value. So we know that K is equals to P by 0.125. We can write here as K unsoaked equals to P value for unsoaked by 1 point or 0.125 in centimeters. Also for K soaked, we want to calculate the value of K soaked. This is P soaked. Soaked means damped, 0.125. We want to calculate the value of K soaked. We can combine this relation to find K soaked as K soaked is equals to K unsoaked multiply by P soaked by P unsoaked. There may be some relation given in examination about these values, and you may be asked to calculate another value. So you can use these relationship to calculate the worst condition scenario. There may be case 2. What case 2 is? We may have calculated this CBR value using another size of plate when different size of plate is used. When different size of plate is used. What plate is used? Let us say we have used 300 plate. So we want K 750 The relationship between the K 750 and K 300 is given as 0.5 K 300. If you have 300 plate, the value of subgrade reaction, the value of modulus of subgrade reaction at 300 plate, you can multiply it by 300 by 0.5 and calculate the value of subgrade reaction at 0. Or subgrade reaction for 750 This relationship can be, this is a relationship given by IRC, Indian Road Congress Code. This relationship can be obtained by a theoretical relation of your for your rigid payment or for your flexible payment. For a rigid payment, and your flexible payment, we have value of this settlement delta as 1.18 into P A by E. Similarly, for flexible payment, the settlement value is 1.5 P A by E. Here E is Young's modulus for plate material. P applied stress, the P which we have already seen. A is the radius of contact area. So from this relationship, we can say P by delta equals to E by 1.18 times A. For a value of delta, for value of delta as 1.25 or 0.125 centimeter, we can write this equation as K is equals to E by 1.18 times A. We can take A here, Ka is equals to E by 1.18. This is a constant. So we can write this equation as K1 A1 is equals to K2 A2. With this relationship, we can generate the relationship between K value of different diameter plates. If we say 1 is for 300 dia and 2 is for 750 dia, We can write this relationship as K 300, A is your 300, A2 is your 750 mm, and A2 is your 750. What we want? We want this 750 mm value. A 750 is equals to 300 by 750 multiplied by K 300. So from here we get a relationship as K 750 is equals to 0.4 times K 300. We have already used similar kind of relationship, that K 750 is equal to 0.5 K 300, and this is a theoretical relationship again. K 750 is equal to 0.4 K 300. So this is how you can calculate the value of modulus of subgrade reaction for different diameter of plates using a different diameter of plate. These two relationships which we have written are very important. These may be asked directly into your examination. Any of the value can be provided and other values can be asked. So you should remember these relationship. Their results need not to be remembered whatever we have done kind of derivation, but the initial results should be remembered in terms of rigid pavement and for flexible pavement. So let us move on to another test, which is our CBR test. CBR is California bearing ratio. Let us first understand what we are doing here. We are calculating the ratio. What is the ratio? CBR is actually a ratio of load beared by your sample, whatever sample you have, to load beared by or taken by standard sample. Standard sample is your standard rocks or standard aggregates. What is done in a prepared sample, plunger is used to apply some load, and for different settlements these loads are measured. For two values, 2.5 mm settlement and 5 mm settlement, these ratios are calculated. For 2.5 mm settlement, what is the load taken by the sample divided by the load taken by the standard material for 2.5 value, and for 5 mm settlement again the same value or the same ratio is calculated. Generally, with increase in settlement, this CBR value decreases. But if the CBR value for 5 mm is greater, we perform this test again, and if again we find the 5 value greater, then we take CBR value as 5, CBR value corresponding to 5 mm settlement, and we use this value for design of flexible pavement. So let us see what is the test arrangement and test procedure. This CBR value is actually very important for design in flexible pavement. In coming lectures, we will see design of flexible pavement, and there we will find the importance of CBR value. In this test arrangement, these instrument is used. This is the mold. Mold has a collar. The actual height of mold is 127 mm. The dia of this mold is 150 mm. This mold is placed over this arrangement and a collar is fitted over the top. A perforated plate or a solid plate comparative to what condition you want to test in, like The site condition may be damp condition or soaked condition. So you may soak this sample for around 48 to 96 hours. If you want to test it at dry density level, because what you do at site, you compact your soil at the level of or to the level of dry density. You know that what is dry density? It is the maximum possible density of soil. And to calculate this dry density, we perform either Proctor test or modified Proctor test. Through these tests, we calculate the optimum moisture content and the maximum dry density. Optimum moisture content is that moisture content which will give or which help us to attain the maximum dry density. So we will do Proctor test and calculate the OMC value. We will add that amount of water into the soil present with us and compact it into these mold. What is the compaction level? We'll talk about it. So compaction is done, compaction is done. Then for soaked condition, it may be kept in water bath for 96 hours and then it is taken out. Some surcharge weight is placed over it in order to give the actual site condition, because at site over a subgrade there will be some surcharge, and then it is placed in this loading arrangement. Here we have a dial gauge which is calculating the strain value or the settlement. Here the proving ring is calculating the load applied. So what we do, we take this mold, we can perform this test by light compaction or with heavy compaction. In light compaction, 3 layers, the material is filled in 3 layers, and compaction or blows of around 56 blows for each layer is provided. The hammer used for light compaction is of 2.5 kg. Similarly, for heavy compaction, the same mold is used, but we fill the material in 5 layers. Same 56 blows for each layer. But the hammer used for heavy compaction, hammer used is of 4.89 kg. I want you to remember these values because sometime these values are asked, maybe not in your GATE examination, but in MTech interviews, because MTech interviews are, they sometimes emphasize more on your practical knowledge or your laboratory knowledge. So you should remember these values and the basic concept behind the experiment which you are performing. So this is done, this is prepared. Now after preparation, a surcharge load is placed over this soil mass. Surcharge load replicates the site condition in the laboratory, because at subgrade level there will be load present. So to replicate, we put surcharge load. As we already discussed that if there is soaked condition at the site, we should apply or we should put this sample into water for 96 hours. Now For testing, we place it in here, and this is the plunger which is allowed to move into the soil, and the load which is required is measured by proving grid. This plunger is 50 dia, or has a what we call it area of 19.62 centimeter square. So 50 dia should be remembered. This plunger is allowed into the soil sample, and the values of deflection versus load is plotted. This is your penetration. I forgot you to tell you about the strain which is applied. Let us write this also. The proving or the plunger is allowed to move down by a rate of 1.25 mm per minute. Okay. So penetration versus load curve is made. This curve generally comes out of this. Penetration values are measured for every 1.25 mm, or you can measure it for 1 mm, or you can measure it for 2.5 mm. Because we need the values for 2.5 mm and 5 mm settlement, we can take the load values from here. Sometimes there happens that here there is concavity, some concavity is there, and then the curves start to move in the required direction. So to eliminate this concavity is because of the soft surface present over this, or some impurities or some undulations present over the surface. So if you see deflection, more deflection with less load, the concavity means deflection is more with less load. So we can ignore this concavity by drawing a tangent from this path, and then we will calculate the value of load for 5 mm and 2.5 mm settlement. Now we have load for 5 mm and 2.5 mm settlement, standard load or load for standard material. Load for standard material. This you should remember. Always you should remember this. For standard material, for 2.5 mm settlement, the load value is 1370 kilograms, and for 5 mm settlement, the load value is 2055 kilograms. So the CBR value is calculated. CBR value for 2.5 mm settlement is calculated as load for sample divided by 1370 kilograms. CBR for 5 mm, this is load for given sample at settlement of 5 mm divided by 2055. So out of these two values, maximum value is U. Most of the time, 2.5 mm settlement gives you CBR maximum. But if 5 mm give you more CBR, you should repeat the test. If still 5 mm gives you more CBR, CBR for 5 mm should be used. So this is all about CBR test. We had a mold, we filled it by light compaction or heavy compaction up to dry density or at the site condition. We placed the surcharge load. For soaked condition, we put it in water for 96 hours. Then we put it in this loading arrangement. We calculate the load and we calculate the settlement or penetration. This load penetration curve is made and the value of load at 2.5 mm penetration and 5 mm penetration is calculated. Then CBR, the ratio is calculated for 2.5 mm settlement and 5 mm settlement with comparing with the standard material. For 2.5 mm settlement, the load for standard material is 1370 kilogram, and for 5 mm settlement, the load taken by the standard material is 2055 kilogram. So these values are used and CBR value is calculated. Now, how we use this CBR value or how we use the value which we calculated here for plate load test or modulus of subgrade reaction in design of pavement, this we will see in pavement design only. So for now, thank you so much. We will meet in next class with some another material. Thank you so much.